start the recording semula. Kita break tadi 10 minutes. So now I'm going to share the slides on this number system. Okay. Everybody can see the slide?
Boleh, sir.
Boleh, okay. Now, we go into lecture 6, which is the chapter 2 of the Floyd Digital Fundamentals, the textbook, Floyd Digital Fundamental. So, today I'm going to cover most probably part of the number systems. I'm not going to cover much, because of course you'll be a bit tired lah kalau panjang sangat, the lecture. Okay, the number systems. A number system is a code that use symbols to count the number of items. For example, let's say that number system of decimal, which is a base 10. So they are used base 10, so it uses 10 symbols. What are those symbols? Anybody? For decimal?
Apa tu?
What are the symbols for the decimal, for the base 10 numbering system?
Bin.
No, I want those 10 symbols.
Bukan tak ada.
Sekejap.
0 sampai 9. 0 sampai 9.
Yes. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are the 10 symbols. And in this course, we are going to cover those 4 systems, 4 number systems. The binary is a base 2. So we use 2 symbols. What are those symbols?
1 and 2.
And 2.
Base 2.
Base
What is the symbol?
0.
0,
And
1, 2.
0 and 1.
1.
What is the octal?
Oh, 0 to 7.
0 until 7.
So 0, 1, 2, 3, 4, 5, 6, 7. What is the hexadecimal?
0 until
15. 0 until 15.
No.
Eza 0 until 9.
Until 9.
D, E, F.
Dia limited number until 16.
So basically that you have 16 symbols. What are those symbols? The symbols are like Uzwatun said, 0 to 9, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then after that, A, B, C, D, E, and F. F represent as 90 as a 15. So that is F. Okay, so those are the basis, the symbols for those 4 numbering systems. Okay. Now we go to the decimal numbers. The decimal numbers numbering system has 10 digits, which is 0 through 9. Just like we said just now. The decimal numbering system has a base of 10 with each position weighted by a factor of 10. So increases basically 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4. So basically any digits in that particular location, basically the first location will be a unit of 1. For example, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. If the number is at the second location, which is at the location of 10 to the power of 1, basically that is actually the but it becomes 10, 20, 30, 40, 50, 60, 70, 80, and 90, right? So for the third location, which is at 10 to the power of 2, so basically that becomes 100, 200, 300, 400, 500, 600, 700, 800, 900, and so on, right? So anything that on the left, on the right of the decimal point, this is decreasing, 10 to the power of minus 1. The next location, 10 to the power of minus 2. The next is 10 to the minus 3, and so on. So for example, if you have a number 372 in the decimal system, you can express as 3 times 10 to the power of 2 plus 7 times 10 to the power of 1 plus 2 times 10 to the power of 3. So you have 300 plus 70 plus 2. Clear? Clear or
Apa
not?
contoh negatif
Clear,
one?
sir. Clear, sir.
Huh?
Apa contoh negatif one, sir?
What, negative?
Negative 1.
One.
Negative 1.
How?
Negative 1 is basically that
Bila dia negatif. Nombor tu
Point
negatif.
something.
number negative. Number negative in decimal, how do you indicate? With a negative sign, right?
Oh, decimal.
Right.
Okay, faham.
In the decimal, you represent with a negative sign. So this is actually express the decimal number 568.23.23 as a sum of the values of each digit. So this is how you do. 568.23. So 5 is at the third location. So third location is basically that 10 to the power of 2. So 5 times 10 to the power of 2 plus 6, which is on the second location, which is times 10 to the power of 1. And 8 is basically 10 to the power of 0. Plus, then the ones that on the right of the decimal point, the first one is at 10 to the power of minus 1. So 2 times 10 to the power of minus 1 plus 3 times 10 to the minus 2. So you work it out. So you have this 500 plus 60 plus 8 plus 0.2 plus 0.03. Yeah. So this is actually the weightage. So this is actually the weightage. Yeah.
Weightage.
Yeah. So the weight that you multiply by the factor, this is the factor. So for the decimal system, the factor is 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, which is on the left of the decimal point. If it's on the right, then it's 10 to the power of minus 1, 10 to the power of minus 2, 10 to the power of minus 3, and so on. Right? So the same concept we use for binary numbers. So for binary numbers, you have only 2 digits, zeros and 1. So in the base 2 system with the position of 1 and 0 indicate its weight or value within the number. So the weights in a binary number are based on the power of 2. So if just now we saw in the decimal is that is 10 to the power of 0, 10 to the power of 1, 10 to the power of 2. So in base 2, in the binary, because it's base 2, therefore you have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. And the number which is after the on the right of the decimal, then you get 2 to the power of minus 1, to the power of minus 2, and so on. Right? So the weightage actually is that you have 1, 2, 4, 8, 16, 32 to the right, to the left of the decimal point, and for the ones that on the right of the decimal point, 0.5, 0.25, 0.125, 0.0625, and whatnot. You divide by 2, divide by 2, divide by 2. Clear? Clear? Or
Yes.
you're confused? Anybody clear? Everybody clear?
Clear, sir.
Okay.
Jadi apa maksud dia dengan 10 sir?
Which one? 10. Which one? Here.
Two, one.
Yes.
One or
Position of 1 or 0 indicates its rate or value.
Yes. In the base 2 with the position of 1 and 0. For example, let's say you have 1 here. So basically it means that 1 times 2 to the power of 0. If 1 here, it means that 1 times 2 to the power of 1. So if it's 1 here, so basically that 1 times 2 to the power of 4. Just like here, just like this. In decimal, it can be 0 until 9 here. It can be 0 until 9 here. It can be 0 until 9 here. So what? But based on the position that the number is in, you multiply by the weightage. So the same thing as this. So at each position, it can be ones and zeros because you only have 2 possibilities because it's a binary. So depending on the position, you multiply by the weightage of that position. Clear? So for the binary, the weightage is 1, 2, 4, 8, 16, 32. After 32, what? After 32 is what?
64. 64.
64. After 64, 128. After 128, 256. After 256 is 512, and so on.
Okay.
So, how do we convert the decimal to binary? How you present 0 in binary? So basically that 0, 0, 0, 0. What is 1? 1 is 0, 0, 0, 1. If you represent in 4 bits of binary number. So 2 is 0, 0, 1, 0. 3 is 0, 0, 1, 1. So do you understand this part? The binary number. How you present the decimal into binary number.
So maknanya first row untuk power of 0. Second row power of 1.
No. Column. It's column.
Okay. Column.
Position. This is actually
Column.
2 to the power of 0. This is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3.
Okay.
So 0 is of course 0. But 1 is basically 2 to the power of 1 times 2 to the power of 0 is 1. 2 is 2 to the power of 2, which is 2.
Then plus 0.
And 3, yes. And 3, basically that 2 to the power of 2 is only 2. And you have 1 remaining, which is at 2 to the power of 0. 1.
So dia
the
memang
same thing for
base number dia 2 je, sir.
binary, the base number is 2.
Okay, sir.
Decimal base number is 10. Octal base number is 8.
8.
Hecta base number is
16.
So that is the concept. Okay. So this is how you convert the binary, the decimal into binary. So if you have 15, up to 15, therefore you need 4 bits to represent the decimal number of 15. If it's 16, how many bits that you need? It's 16.
15.
16. If you want to represent 16, how many bits that you need?
4. 5.
Yes. You need 5.
0.
Yes, you need 5 bits of binary number to represent the 16 in decimal. Clear?
Tapi sir kan,
Now, for example,
Megan.
if you have a number of 10110, so you want to convert into decimal. So what you do is that you take each position, for example, example, 1011. So you have how many? 1, 2, 3, 4, 5. So basically you start from here, 0. So 0 times to the power of 0. 1, 1 times to the power of 1. So another 1 times to the power of 2. And the next one is 0 times to the power of 3. And 1 times to the power of 4. So you set this equation, basically that you start from the back. Then after that, you can just calculate lah. So 1 to the power of 24, 1 times 2 to the power of 4 is 16. 0 times anything is 0. 1 times to the power of 2 power of 2 is 4. 1 times to the power of 1 is 2. And 0 times 2 power is 0. So you have 16 plus 0 plus 4 plus 2 plus 0. So altogether it's 22. So this number in binary is equivalent to 22 in decimal. Okay, clear? For this number, 10.011, if you want to convert into decimal system, so you start from, okay, the first one is that you find where is the point. So you have the point. So therefore that you have 2 to the left and 3 to the right. So the ones that to the left, you start from this 0. So 0 plus 0 times to the power of 0. And this one is 1 times to the power of 1. Then you go to this one. So you start from the one that's next to the dot. So this is 0. So 0, basically that times to the power of minus 1. And the next one is the 1 times 2 to the power of minus 2. And the last one is 1 times 2 to the power of minus 3. So when you have set up this equation, therefore you can just multiply and add up. So 10.011 is equivalent to 2.375 in decimal. Simple. Clear?
Clear.
Any questions so
Yes, sir.
far?
Yes, sir.
Okay. So bits is actually short for binary digit, and it has only one digit. It is either 0 or 1. So when we say bit, it means that 0 or 1. When you have 4 bits, it's called a nibble. So for example, 1011 is 1 nibble. It can be any number as long as it's 4 bits. It's called a nibble. A byte contains 8 bits. It can be any number as long as it's 8 bit, then it's called a byte. So for example, your hard disk, you call it 1 terabyte or 1 gigabyte. Remember? Or your USB storage, you have 32 gig.
Oh, yes, sir.
Gig is
Yes.
therefore
Oh,
gigabit or gigabyte. And words is actually 16 bits. It's a word. One word is equivalent to 2 bytes. 1 byte is equivalent to 2 nibbles. And from that number, let's say from this 1 byte, okay, you have the most significant bit, which is the leftmost, and least significant bit to the rightmost. MSB and LSB. So that is the term that we use. Least significant bit is basically that when you multiply by 2 to the power of 0. And most significant bit, then you multiply by the highest weightage, to the power of what? If it's 7 bit, then basically you multiply by 2 to the power of 6. If it's 8 bits, to the power of 7, because you start from to the power of 0, right? So the factor is that this is 0, 1, to the power of 1, to the power of 2, 3, 4, 5, 6, and 7. This is a byte. If a neighbor, so this is a to the power of 0, to the power of 1, to the power of 2, to the power of 3. If it's a word, this is to the power of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is actually 2 to the power of 15. So it depends on the position. So in this case, this is really the least significant bit, and this is the most significant bit. So this most significant bit is the value, the weightage is to the power of 3 for a neighbor. For a byte, the most significant bit is to the power of 5, to the power of 7. For word, the most significant bit is to the power of 15. Yes. Okay. So this is the conversion of binary to decimal conversion. How do you convert? So the decimal equivalent of any binary number can be determined by adding the weights of all bits that are ones and discard the weights of all bits that are 0. So for example, if you want to convert the binary number of 110101 to decimal, so what you do is that first you write the binary number, then after that you write this the weightage starting from the least significant bit until to the most significant bit. Then you multiply. So this one is basically 1 multiplied by weight is 1. This one is you take out because it's 0. Multiplied by anything is 0. Then this one multiplied by the weightage, which is 2 to the power of 2, which is 4. So 1 multiplied by 4 is 4. And the next one is 2 to the power of 3, 8. This one you take out. Then 2 to the power of 5, 32. And 2 to the power of, then the most significant bit is 2 to the power of 6, is 64. Then you add up all together, then you get 109. So that is how you convert a binary to decimal. Clear? Clear? Simple, right? So now, if you want to do the other way around, from decimal to binary conversion, if you are given a binary number, a decimal number, and you are asked to convert into binary, you have two methods of conversion. These two methods are called sum of weights method, and the second one is repeated division by 2 method. Okay? You have two methods. The first method is determine the sum of weights method, basically that you determine the set of binary weights whose sum is equal to the decimal number. For the second one, repeated division by 2 method, you do repeatedly dividing the decimal number by 2 and retrieving the remainder. So we will see how these two methods are done. Okay. This is actually sums of weights method. For example, you need to convert the following decimal number to binary. For the first one is 12. So how do you do that? 12. Tak dengar? Dengar tak suara saya? Dengar? Can you hear me?
Can, sir.
Can you hear me? Okay.
Okay.
So let's say that you want to convert
Can.
the following decimal numbers to binary using the sum of weights method. So 12. Okay, basically that first you have to remember this weight. The weightage is at 1, 2, 4, 8, 16, 32, and 64. So if it's 12, 12 is basically that the summation of 8 and 4, right?
Apple.
8 and 4. So basically that you have 2 to the power of 3 plus 2 to the power of 4. Okay. 2 to the power of 3 to the power of 4. So you see that this is the highest weightage. Is actually the MSB is at the fourth location because you start from 0. So therefore, you convert into 1100 because the 2 to the power of 1 and 2 to the power of 0, this actually multiply by 0. So you get this. What about 84? 82. 82 is basically that after 64 is 128, right? So 82 is lesser than less than 128. So therefore, the highest that you can go is 64. 64. Then after that, the remaining is how much? 82 minus 64. 82 minus 64, how much?
18, sir.
18, right?
18, sir.
18. 18.
18. So 18 is actually in between of 32 and 16. So therefore, you take 16, right? So 64 plus 16. What is the remainder?
2, sir.
2.
2.
So 2 is basically, you take this. So 64 plus 60 plus 2. So this is actually the weightage for each. So 64, 16, and 2. So you convert. 64 is actually 2 to the power of 6. 16 is 2 to the power of 4. Then 2 is 2 to the power of 1. So you have 1, 4, and 6. What it means is that the highest, the most significant bit is actually with a weightage of 2 to the power of 6. So you are actually, this number actually will be in, you have 7 digits. 7 bits, bukan digit, 7 bits. Okay, because the highest is 6. So 6, 5, 4, 3, 2, 1, and 0. And you put a 1 for the ones that you have this weightage. 6, 4, and 1. So 6, 4, and 1. So the rest are zeros. So therefore, 82 is actually 1010010. So that is the binary representation of a 82 in decimal system. The third example, 125. So 125, the highest actually 64 because the next one is only 128. So it's 64. So 125 minus 64, you leave with what? 60, 50 something.
Yes, sir. 61, sir.
61. So 61 is less than 64. So you cannot take 64. So it's the next weightage is 32. So you
Yeah.
plus 62. So 61 minus 32,
29.
29.
29. 29 is actually the next one is 16. So you take 16. So 29
16.
minus 16,
13, sir.
13. 13 is basically you take the 8.
8.
So 13 minus 8 is
5.
5.
5. 5, then basically Here is basically
4
you
and
take
then add
4.
1.
4, then the remainder is 1. So then you write based on the position 6, 4, 5, 6, 5, 4, 2, 3, 2, and 0. So you know that you have a 7 digits. So this is 1, 1, 1, 1, 1, and to the power of 1 is 0, and the last one is 1. So this is the equivalent. So 135 in decimal equivalent to 1111101 in binary system. Simple. That is the first method, sum of weights method. But the simplest, the easier method is called a division by 2 method. So these are the steps of doing the division by 2 method. You take the decimal number, you divide by 2. Then you record the quotient and the remainder. So you write the remainder after each division until a quotient of 0 is obtained. So you continue doing that. You divide by 2, divide by 2, divide by 2, divide by 2 until the quotient is 0. When the quotient is 0, you collect the remainder in the desired binary numbers with first remainder as the least significant bit and the last remainder as the most significant bit. Then you end. So this is the method. Let's say you have 19 in decimal, you want to convert into binary. So what first you do is that 19 divided by 2 is 9 with a remainder of 1. Now you take the 9, you divide by 2, you got a 4 and the remainder of 1. You record the remainder here. You record the remainder.
Macam matematik form 3.
Apa benda?
Macam
Yang kita
matematik form
pernah
3.
study
Yang
dulu.
lowest,
Yes.
highest common factor. Lowest
Yes.
common factor tu.
Yes. Then after that 4, you divide by 2, is 0. The remainder is 0, but the quotient is 2. 2 divided by 2 is 1. The remainder is 0. So 1 divided by 2 is the quotient is 0. The remainder is 1. Then you stop since the quotient is 0. When you stop, then you write this is the first remainder is the least significant bit and the last remainder is the most significant bit. So do you write 1, 0, 0, 1, 1. So you write 1, 0, 0, 1, 1. So therefore, 19 is equal to 1, 0, 0, 1, 1 in binary. So I prefer this division by 2 method instead of sum of weights method. So that is my personal preference. So for 45, which one do you prefer?
Edit and sum.
Sum of
First.
weight.
Yang ni tak faham sangat, tak faham sikit.
Saya tak faham. Where you confused? Which part? Which
Dia dah
part?
bahagi. Dia dah bahagi dan sampai 0.
Okay, for example, 19, you divide by 2. So this is division by 2. So 19, so you take the number, you divide by 2. So 19 divided by 2 is 9 plus remainder of 1. So you record the remainder here. Then you take the quotient, 9, you divide again by 2. So you get 4 with a remainder of 1. So you record the remainder. Then you take the quotient, the 4 just now, you divide by 2 again. So you get 2 with a remainder of 0. Then you take the quotient again, you divide by 2, you get a 1 and remainder of 0. And you take the quotient 1, you divide by 2, is equal to 0 and remainder of 1. When the quotient is equal to 0, you stop. You don't go anymore. You don't continue because you are done. Then you write based on the this MSB. Basically, you write from the bottom to the top as your solution.
Sir.
So you get 1, 0, 0, 1, 1. Okay.
Sir.
Yes.
Apa ni kalau okay ini untuk binary kita divide by 2. Kalau yang lain kita follow lah macam 4A. Kalau 16 macam mana sir?
16 you divide by if it's
On the spot.
a hexadecimal, you divide by 16.
Oh, that's all lah sir. Alright.
Nanti tengok lah after this. Now we are actually doing the binary first.
Binary conversion.
Okay.
The resolution.
Okay. Now it's actually for the next example is 45. So for 45, if you divide by 2, is equal to 22 plus 1 remainder, right? So you write the remainder as 1 and the quotient is 22. You take the quotient 22, you divide again by 2. So you get 11 and there is no remainder. So the remainder is 0. Then you take the quotient 11, divide by 2. You get a 5 and remainder 1. And you take the quotient 5, divide by 2, you get 2 with a remainder of 1. And 2, you divide by 2, you got a quotient of 1 and remainder of 0. And 1, you divide by 2, you get to 0, the quotient is 0 and remainder is 1. And you stop because the quotient is 0. You cannot proceed further. Then you read from the bottom, which is MSB to the LSB. So 1, 0, 1, 1, 0, 1 as your answer. So always read from the bottom if you do the divide by 2 method. Okay. Converting decimal fractions to binary. 2 methods to convert decimal number to binary. Sum of weights, just like the first one, is determine the set of binary weights whose number is equal to the decimal number. But the second one is repeated multiplication by 2. Just now it's actually the whole number. Whole number, you use the division by 2. But if it's a fraction, you use a repeated multiplication by 2. So repeatedly multiplying the decimal number by 2 until no fraction terms are left. The carry digits or carries generated by the multiplication produce the binary number. The first carry produced is the most significant bit and the least carry is the least significant bit. So this is the first one, same like the first one, like the what do you call it, the whole number, the whole decimal number that you want to convert into binary. For example, is let's say that you want to convert 0.625. So 0.625 is basically that greater than 0.5. So the first one is actually 0.5. Then what is the remaining? The remaining is 1.25. 1.25 is actually to the power minus 2. So basically the answer is 0.101. So this just like this previously, the sum of weights method. 45.5. So 45.5. So it's actually between 64 and 32. So you take the 32. So 32 minus 45.5, 45.5 minus 32, you get how much? 13.5. 13.5 is between 16 and 8. So basically it's an 8. So you take an 8. So 13.5 minus 8.
0.5.
Then you get the 4. 4 minus is basically you leave it 1.5. So basically 1. You take the 1 here. And you leave with a 0.5. 0.5 basically this is the one. 0.5. Then you convert into this weightage. So you get 101101.1. So that is sum of weights method. Now it's repeated multiplication by 2 method. Ini terbalik daripada previous one. Basically now, when you have the fractions like this, you use a multiplication by 2. Instead of divide, you multiply by 2. You take the original number, you multiply by 2. When you multiply by 2, let's say 0.3125. Multiply by 2, you get 0.625. What is the carry? 0. Because it's not a 1. So it's 0.
Apa dia
Zero.
zero? Tak faham ini.
Sebab tak ada dia punya lebih.
Dia tak ada 1 sini. It's 0. 0.625.
Okay.
So there is no carry.
Dia
So you
macam
take-
lebih kurang reminder rasa kan? Okay.
So basically you take the one that is before the decimal point. So 0. Then you take 0.625. 0.625 multiply by 2, you get 1.25. So you have a carry of 1. So you put a carry, but for the next one, you take this decimal part of it, you multiply by 2. So 0.5, so basically 0, so the carry is 0. So you take the decimal part of the decimal part of it, 0.5, multiply by 2, then you get 1.00. You stop when this decimal portion is equal to 0.
0, then stop.
Stop. Then you read this.
1, 0, 1, 0.
0, 1, 0, 1.
Oh, okay.
Not
Balik.
from the back.
Alright.
For the multiplication of 2, you read from the top, from the MSB. So 0, 1, 0, 1. So 0.3125 is equal to 0.0101. This is the multiplication by 2 method. And another example, 0.375. And you want to convert into binary. So 0.375 multiplied by 2 is equal to 0.75. So 0 is the carry, and 0.75 you multiply again. So 0.75 multiplied by 2 is equal to 1.5. So 1 is the carry, and 0.5 you multiply again because it's not 0. So 0.5 times 2 is equal to 1.00. So 1 is the carry, and when you have 0, 0, then you stop. 0, 0 after the decimal point. So therefore, you read from top to bottom, 0, 1, 1. So 0.3125 is equal to 0.011 in binary. Okay, now, this is a bit more complex. Now you have 65.6875. So you have to then you have to break it into 2. The whole number 65, you use the method of division by 2, and the decimal, the fraction part of it, you use the multiplication by 2 method. Then for this one, you read from bottom to top for the whole number, and for the fraction part, you read from the top to bottom. Then after that, you combine.
All right.
Okay. Clear.
Clear, sir.
What time is it now?
12, sir.
12. So let's see where we are. So we want to continue to binary arithmetic, or we want to stop here?
Up to you, sir.
Up to me, because this one actually we plan for about 2 hours, right? So let me see. This one is a bit heavy, so maybe I stop here and we continue on on Thursday for the binary arithmetic. So most probably that on Thursday, we continue binary arithmetic. We go to signed numbers, then hexadecimal, octal, then we are done. So hopefully that next week we can, this Thursday we can finish this whole part. Okay, so I stop here. I stop at binary arithmetic. We continue from the binary arithmetic on Thursday. So any question so far?
Yang table tu je saya tak faham.
No, sir.
Huh?
No.
Which
Yang
one that
table
you that you didn't understand?
Yang zero, yang binary tadi. Ada table besar.
Which one? Which
Yang
table
dia
besar?
division tu ke? Division method.
This one.
Lagi.
This
lagi.
one you didn't understand.
That one sir.
This one.
Bukan
This
yang
one.
table besar. Yes.
This one is basically you convert the decimal to binary. You can use two methods to do.
Oh, faham sir.
Then basically you can use this method or sums of weight method or repeated division by two method. Okay?
Okay, faham sir.
Okay?
Okay sir.
So any other question? So this one will next week on Thursday. This part.
Sir,
Yes.
apa ni chapter ni ada dalam assignment 3 yang sir?
Assignment 5.
Oh,
I
okay.
think.
Alright.
Assignment 5, I think. Okay. Okay. So any question? So if not, then I will what to call it? Okay. If not, I will stop this record the sharing first. Okay. So if you don't have any question, I will stop the recording. Okay.
Okay sir.
Okay, thank you.
Okay,
So
sir. Thank you.
anything that you can send through WhatsApp or email for any clarification that you need on this lecture. Okay. Right now it's 12:05. So thank you. We see you on Thursday.
Baik sir.